All right, so we're gonna explore further in terms of dipole moment, okay, of the molecules, right? Or to determine the polar or non-polar. We're gonna use it in terms of solvent. Why do we need to know this? Well, selecting an appropriate solvent for a reaction is really, really important. First off, you have to be able to dissolve reagent or the compound into the solution. Otherwise, you can't do anything with it if it doesn't get to the solution. Okay, selecting an appropriate solvent is really important. All right, to determine that, let's start with the basic here. So I have two compounds for you. We have methanol on the left side and decanol on the right side. Okay, now both are polar compound. Do you know that? Of course you do. You see an OH bond, water, alcohol, they are polar compound. But who's more polar or who's less polar? Okay. Now let's think about this. Methanol is polar because of the OH bond. Hold on, right there. The OH group. Okay, the alcohol group. All right. The CH3 is still there. That's a non-polar group, but the overall methanol is polar. All right. Now let's consider decanol. Decanol is polar because of the OH group right there, right? But here's the thing though, decanol have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, deca means 10. So 10 carbon there. The non-polar group is really, really big. So if you compare the polarity of methanol and decanol, you can see that, well, methanol is small. The polar group is the same. They have the same polar group there, right? Same strength with a small structure. Methanol is going to be polar, but decanol, the non-polar group is really, really big. And they just trump the effect of polarity from the OH. So decanol is actually not that polar. All right. So when you consider the polarity of the compound or the solvent, you have to consider the whole molecule, the size of the molecule. If the polar group is real small, but the non-polar group is really, really big, that guy is actually non-polar. Okay. So we have the term dielectric constant, use ether. That's a great term. As a dielectric constant, basically it's the polarity of a molecule that consider the size per unit volume. Right? Consider the size of the molecule. Right? If the molecule is really big and the polar unit is really small, it's not polar, non-polar. Give you some example here. Take a look at this 4 alcohol. Okay, we have methanol, ethanol, isopropanol, tert-butanol. Right. If you look at the dipole moment, they have pretty much the same dipole moment right there. The mu right there, that's dipole moment, right? Because the polarity or dipole moment of this compound comes from the OH bond, OH group. They have similar, 1.7, 1.69, 1.66, 1.66. Yep, same strength. But if you consider the size of this alcohol, tert-butanol is the largest one, right? And that will reduce the polarity of the compound. So look at the dielectric constant. Consider the size of the molecule, only 10.9. Methanol is the smallest one, 32.7. Okay, so in this case, methanol is the highest, has the highest polarity, and tert-butanol is the least polar compound here. All right. Now look at the solvent right here. So I divided solvent. I categorize solvent into 3 groups, right? The top one, this guy are polar solvent, right? Look at water. Water is real polar from the oxygen, right? But think about it, water is really, really small. So the polarity of water shine, right? Really dominate the whole compound. So water is one of the most polar solvent. All right, methanol, also, you probably heard about it, and acetone. Okay, this guy are polar solvent. You might have heard acetonitrile, maybe some of you. This one, I don't think you have heard before. So dimethyl sulfoxide, so DMSO, and dimethylbromamide, DMF. Okay. All right, but I'm sure you know water, acetone, methanol. These are the main three of the polar solvent. Okay. All right, come down here. We have kind of polar solvent, not as polar because of the molecules are larger. All right, so we have ethyl acetate and acetic acid. So these two are the main one that you're gonna see. Maybe you will see like tetrahydrofuran a few times in this course. Okay, or THF. All right, and methylene chloride maybe sometimes in this course, but not a lot. But you're gonna see a lot more for ethyl acetate and acetic acid. Okay, and down here if you look at dielectric constant, it's really, really low, hexane 0 right there. All right, this guy, this group right here is a non-polar solvent, right? So diethyl ether, hexane, those are the main one. You might see toluene, benzene sometime, and carbon tetrachloride. Tetra means 4, so there are 4 chlorine there on the carbon in the middle. All right. All right. Now, this is how dissolving compounds work, or we call solvation. You might have heard I say solvation a few times in a couple chapters down the road. Okay, so solvation or dissolving compound. So how does it work? So sodium chloride, a solid sodium chloride, you guys know it's ionic bond, salt. You get sodium ion and chloride ion. How does water dissolve it? Well, think about right here. So water is a polar compound, polar solvent. So oxygen is partial negative, hydrogen partial positive. Okay, so to dissolve sodium chloride, water have to go surround it. Right, it have to go surround each ion, sodium ion, and each chloride ion. Right, now sodium is positive. Oxygen have to attract not oxygen, so water have to form interaction with the sodium ion. What does water do? Well, sodium positive, so I'm gonna need the negative N in this whole molecule. Oxygen is negative. Right, so it attracts positive, negative, they attract right there. So you should look like this. So sodium ion in the middle, and all oxygen comes around it, or we call solvate sodium, like that. All right. Make sure you know how to draw this structure like right here. So if I ask you on the exam, can you draw the solvation of sodium ion and water? Should be able to put oxygen around sodium like that. Okay. Chlorine is the opposite though. Chlorine is negative. So that's not going to be water negative on chlorine and partial negative on oxygen. They're going to repel, right? They can't form interaction. What is water going to do? Water going to butt in, right? Water knows that hydrogen is partial positive, so negative, positive, they attract. In this case, I'll take a look here. So chlorine in the middle. So water, instead of using the oxygen, look, no, there's the same charge. That will repel. So we will use hydrogen, which is partially positive charge, okay? And form interaction with chlorine. That's the attract right there. All right. So in reality, so each sodium, you don't need to know this. This will just show you. I took picture from Gen Chem 2. Right. So each sodium ion, they are 6 water surrounded look like an octahedral structure. Okay. Same thing with chlorine. So 1, 2, 3, 4, 5, 6 hydrogen. To surround the chlorine there. Okay. All right. Now, basically, what you need to know is positive and negative they attract. Negative, positive they attract. That's wrong right there. That's oxygen. That has to be hydrogen. You can see that. So oxygen is negative. Chlorine negative. That's repel. So this line have to go to should have gone to hydrogen there. All right. Anyway. Dissolving sodium methoxide, this guy, NaOCH3 in acetone. Okay, so think about it. Who's positive? Who's negative? If you remember, the positive, negative, they attracts, right? All you have to do, find the positive in the compound that you want to dissolve, and find negative or the opposite charge in the solvent. If you find negative here, find a positive in the solvent, basically. Right, so sodium methoxide look like this. You know that this is an ionic bond. You can treat them sodium ion and oxide ion look like that. Okay. Now acetone though, who's negative, who's positive? Well, you can see carbon oxygen bond there. Right, so oxygen is partial negative, carbon is partial positive. All right. Okay, so now just put them together. So start with sodium ion. Okay, so sodium positive, we're gonna take negative end of acetone, which is oxygen, surround sodium like that, form interaction. That's it. Positive and negative. And oxygen, which is negative oxide right here. All right. So we'll pair up with the carbon, which is partially positive right there. Ta-da. That's how you do it. All right. Okay. All right. Let's stop with this video. Let's go to the next one.